warm welcome, everybody, to the next session, to the session Software and Deep Learning. So very exciting topics. And well, I have three speakers here. And the first one, I would like to introduce Mario Bohnacker from the MVTEc Software GmbH. And he will talk about how can and let your application benefit from deep learning technologies. So enjoy, please.
Thank you very much. Yes, my name is Mario Bohnacker, and I'm working for the MVTEc Software GmbH. And in my role as technical product manager of our software library, können, I'm going to show you how your machine vision application can profit by the use of deep learning. Deep learning has seen big leaps in performance in the past several years, and the massive amount of research, products, and frameworks put out can be quite overwhelming. And it's very difficult to figure out which of this development of these products, of these frameworks, can make your machine vision application profit. So today I want to show you 3 real-world machine vision applications from different industries, focusing on how deep learning can bring these machine vision applications to the next level. So the first example I brought with me today is from the food and packaging industry, and it's used the deep learning technology image classification, which basically classifies the image of the content of one image. The task here is to have an inline inspection system of bread package sealing. How does something like this look like? So on the left, you can see one example image from a top view of this inspection. Basically, this task had 2 views, top view and side view. And this shows a good image where the sealing is correctly. But there were a high range of different kind of defects, like shown in the lower example images. On the right, you see a not closed sealing. And on the left, you can see an image in which it's quite difficult to see if it's closed correctly or not. The side view, which was also used for this inspection, looked like this. A small package, but there were also bigger packages, so different kind of sizes, and 2 typical errors of this task here. So what were the major challenges for this kind of application? As you've seen, there have been multiple different sizes of this bread packaging, and you can imagine that each of the manufacturer of this bread has different kind of packaging. So it's not always see-through plastic. There may be some prints on it and other different artifacts. So far, this task was solved manually, manual inspection on a random basis, but this was not sufficient, as problematic products caused machine downtime in following processes, like, for example, picking from a robot was not successful, of course, when the package was not closed correctly. So how was this application solved? This application was solved using MVTEc's deep learning tool to label and manage your data for training, to train and evaluate a deep learning model, and then to roll out this on a production machine by the use of MVTEc Merlic. And the result was a generic solution independent of the size and the manufacturer. So basically, it is a deep learning one-solve-all model. No need to change any recipe or something like that. And we could achieve a 100% quality control, which of course reduced machine downtime and increased product quality. With Merlic, it was also possible to generate such kind of front end as you've seen in the screenshot, This is an easy front-end configurator which comes together with Merlic. Another application example is from semiconductor industry. And in this example, we used MVTec anomaly detection, which is a deep learning technology to detect anomalies. Quite simple, right? So in principle, the process in semicon industries are quite stable. So therefore, it is very difficult to generate a high number of defect images, as you don't have high number of defect parts. And usually, deep learning algorithms need a lot of images per defect class to be trained. Two challenges we had to overcome, besides, of course, the high demand on the accurate defect detection of semiconductor industry. In the images on top, you see 3 images without a defect. And basically, this is the kind of images which were used for the training of this anomaly detection. So the challenge that there is no defect image is not a problem for this technology, as you only need good images. You train with good images, a number of 30 to 50, and then you can have results like shown in this example, where the defects can reliably detected, and even the areas where the defect is located can be highlighted. So the big advantages of deep learning in this kind of scenario is that you only need good images for training, and you can come up with only a low number of images for the training, so you don't need the hundreds of thousands of images. A very nice example which shows the power of anomaly detection deep learning algorithms. Last but not least, a third example, which is from pharma and medical industry, and the technology used is instance segmentation, and technology which allows you to classify objects and get pixel-precise results, segmentation results of these objects. The task on hand is a precise and accurate measurement of natural grown structures, like shown here on this image of the Petri dish. And the challenges for these applications are that these organisms and cells, they grow in all different kind of shapes. They grow in different kind of sizes. And as it's visible here, the difference between different types of organisms are only very small. So visually, it's quite difficult to differentiate between them. Another challenge, these structures grow together, they are touching each other, so it's difficult to tell where to differentiate between each. Using instance segmentation, this is not a problem anymore. With traditional machine vision algorithms, this was quite a hard and challenging task. With instance segmentation, you can get an accurate identification of the different types. You can get pixel-precise segmentation results, and then use traditional machine vision algorithms to post-process these segmentation results and measure different features, like, for example, size, area, diameters, and so on, to get an upgraded application. Of course, the problem I've mentioned with the touching areas, instance segmentation is a solution, especially for these areas where these objects are touching each other, and here you can robustly separate using this technology. So with MVTec products, we offer deep learning technologies and solutions for you. With the deep learning tool, which is seen in the middle, we provide an easy entry point to deep learning. It allows the labeling and management of your data set and provides training as well as evaluation algorithms. And you do not need to program any line of code. It's all user-friendly usage. This tool goes hand in hand with our other two software products, MVTec Können and MVTec Merlic. if you're a programmer and you like full flexibility, then MVTec Helken is the right tool to go. You can combine traditional machine vision algorithms with deep learning technologies and get the best out of your machine vision applications. In case your focus is to configure applications and you don't want to program, and you're looking for an all-in-one solution, means machine vision algorithms, PLC communication, as well as a front-end designer, then our tool, Merlik, is your tool to go. In our software products, we provide all deep learning technologies that are necessary for typical machine vision applications. It's image classification to get a decision for one complete image. We have object detection algorithms to detect objects inside an image. We have dimensioned anomaly detection, which works on only good images and can give you a decision of good or bad, and even give you results for interesting areas and anomaly areas. We have algorithms for segmentation, for especially tuned for edge extraction, as well as semantic segmentation. And the latest, the newest, will be the instant segmentation, which basically is a combination of the best of object detection as well as semantic segmentation, and gives you objects, instances, so can be used for counting, but also gives you pixel-precise results, which can be used for further processing of your application. This instant segmentation will be released with Helken 2111, which will be released in November this year. Besides the typical deep learning technologies, MVTec is always investigating in how deep learning technology can be integrated into existing solutions, into existing algorithms, like, for example, OCR applications. OCR is a topic which is widely known in machine vision, and there have been algorithms out there already, and this is one example in which we integrated deep learning to provide a functionality called Deep OCR. No matter what kind of font type, what kind of printing style you have, there's one deep learning model which can read this text, independent of the orientation, as you can see in one of these images. So one important area that we think how deep learning can make machine vision applications better is by combining traditional algorithms and deep learning into one, and not thinking of deep learning as one singular solution. If you're more interested in more details, come and visit us at our booth in Hall 8, C56, right over there. We have some demo videos of our products, Merlix. We have a demo of the deep learning tool, and I hope I aroused your interest, and would be glad to answer more of your questions either now or when you come to visit our booth. Thank you very much.
Yeah, thank you very much, Mario, for this presentation. I wonder that there are no questions from the audience, so maybe you give me the chance to ask something. What I was wondering is, well, you showed a couple of applications, and I guess you have really a lot of different applications from your customer. What is your guess? What is the percentage of applications that are solved typically by deep learning compared to those that are solved by traditional machine vision? So, do you have a guess for us?
It's difficult to say to give a percentage because in our opinion, or in most cases, the solution is not just it's deep learning or it's traditional algorithms. So mostly it's a combination of both. And there are still a lot of applications where deep learning just is not necessary yet. So people always see deep learning and thinking of, I need a deep learning solution, but there are strong machine vision algorithms built over the last centuries, not centuries, 20 to 25 years. And we should not forget about this. This is still very powerful, and as I mentioned, in our opinion, it's always a combination of both which can really bring applications forward.
Okay, then let me ask the other way around. What number of, or what percentage of applications, or rule of thumb, are without machine learning? Is it still the vast majority, or is this
I think
a
at the moment it's
minority?
still the vast majority which is not using deep learning. Can have several different reasons. The expectations may be too high for deep learning. It may be also the deep learning, the trust in deep learning is not there yet in some industries. So applications where deep learning is used don't get FAT because of different kind of reasons. So there's still a lot of work to do to also convince people that deep learning is a trustful technology, and when added up to traditional algorithms can bring these machines applications to the next level.
Okay. Thank you very much.
You're welcome.